Good morning, students. Today I am starting with exercise 4A. We are continuing with exercise 4A, question number 7, and we will do this A part. Before doing this A part, which is on page number 38, students, there will be one formula which we will apply over here. So before doing this before doing this part, I want to explain that formula to you. I will not go in deep, but will explain you to the basic level. We will apply this formula. We will study this formula in later classes deeply, but for now on, just remember that a square minus b square is equals to a plus b multiplied by a minus b. Okay, you just have to learn this formula. Okay, this formula you have to learn. What it says that a square minus b square is equals to a plus b, a minus b, or a plus b, a minus b is equals to a square minus b square. In both ways we can write down. You just have to learn this formula which we will apply in this sum. Okay, now let's begin our sum. Let's see how we will solve this sum solution. Now students, can you see that same base and where powers are given to it, and outside also I can see the power. So first I will apply quotient law over here. How I will apply quotient law? I will apply quotient law of same base. Quotient law of same base says that when bases are same, then you just simply subtract the powers. Powers change their sign, they come up from the denominator position. So I will write a one time and I will write m. This is minus n. When it will go up, it will become plus n. I will close the bracket and I will write what is outside given as a power. Okay, simple. Multiply sign will be copied. Now again, quotient law of same base. A I will write one time, n I will take this denominator power 2 up, so it will become plus L. Okay, don't forget that when you change the positions, you take it to the numerator position. Denominators power change their sign. I am applying quotient law over here. Close the bracket, n minus L, which is given outside. Multiply. Again, a you will write one time, L is already there, minus m you are taking up, so it will become plus m is equals to L minus m you will write there is equals to 1 is given there. I have to prove that this whole given sum is equals to 1. Okay, and let's see will it be proved or not. Now in the next step, what I will do, I will just open the brackets, and this power multiply. Now here what law I am applying? Power law I am applying. It says, power law says that power is raised to another power, simply both the powers multiply. Okay, when power is raised to another power, this is power inside, this is power outside. Whatever it is given, it is power outside. So this power and this power will be multiplied. Same here. So I will apply power law over here, and according to the power law, what I will do, I will multiply the power m plus n bracket m minus n. Now in algebra, you know that way we can put two powers together when variables are given in the brackets, which means that this bracket is completely multiplied by this bracket. This bracket is completely multiplied by this bracket. I do not need to write down multiplication sign in between. Okay, it's obvious that there is multiplication sign. N plus L bracket n minus L multiply by a L plus m L minus m is equals to 1. Very simple. I did not do anything. I just apply power law. This power is multiplied by this power. This power is multiplied by this power. This power is multiplied by this power. Because power law says that when power is raised to another power, you simply multiply the powers. Now, if you remember in the beginning of the lecture, I told you that we will apply a formula. Which formula I said you will apply? I said you will apply a square minus b square formula, which is equal to a plus b minus a plus b in bracket a minus b. So if you can see, a plus b, a minus b. So it is given in this form. If I consider this m and n as a and b plus a minus b. Okay, because when we apply formula, we match that whether they are given the same thing or not. This is formula, so we generalize it. We always write it with a, but it could be any variable. It could be x, it could be s, it could be z, any variable. So the same thing sets over here in all of them. So simply I will apply formula. Apply, you will write apply formula. And you will write which formula you will apply. You will apply a square minus b square formula, which is equal to a plus b, a minus b. Okay, by writing this, now when you are applying, how you will apply the formula a, I have to apply the formula. This a plus b and a minus b is equals to what? A square minus b square. So simply it will be equal to what? M square minus n square. Okay, simple. I did not do anything. I just considered that these variables are equal to these. Okay, because I'm applying formula. So m square minus n square multiply by a, again n square minus l square, because n plus l is equals to a plus b, n minus l is equals to a minus b. So n minus l square, come over here, multiply by a, again l square minus m square. Please do not get confused, do not think it is difficult. It is simply applying the formula. This whole formula is equal to this, so I'm just doing this. If this is given to you, it will be equal to this. Okay, this is given to you, this will be equal to this. Simply I did this. Okay, in the next step, what I will be do, since space is finished, I will rub this. I will not be able to do this whole sum over here. Okay, now looking at this, what do you think? Which law I will apply over here? I will apply product law of same basis. All the bases are same. So what should I do? I will simply add the powers. I will simply add the powers. So let's apply product law of same basis. M square minus n square. Now product law of same basis I am applying, so I will not write a again and again. I will just add the powers. Which sign is this? Plus n square minus l square. Which sign is this? Plus. When no sign is given, it is always plus, minus m square. Now in the next step, you will arrange this like terms. M square is here, minus m square is here, minus n square plus n square, minus l square and plus l square. Okay, is equals to 1. You will write is equals to 1 as it is coming. Now plus m square minus m square cancel. Same variables with opposite sign cancels. This also cancels. This also cancels. It remain only a raised to the power 0 is equals to 1. So hence I have proved. Hence it is proved that this whole thing is equals to 1, because I know zero exponent law that a raised to the power 0 is equals to 1. Any variable raised to the power 0 is equals to 1. So hence it is proved. Okay.